Okay, let's go ahead and get started. Good morning, evening, and afternoon, everyone, depending on the time zone you're joining from. And thank you so much for taking the time. Before we get started, we have the Q&A feature enabled. So if you have a question at any point during the presentation, feel free to put it there and we'll get to them at the end of the presentation. The closed captioning feature is also turned on if you would like to utilize that. I also want to remind everyone that if you want to suggest future speakers in this series, we have a suggestion form that I will put in the chat. It's also on our website. And we really appreciate any feedback from our audience because it helps us to know what you want to hear about. So today, we're delighted to have Dr. Tania Villaseñor join us, who is a geologist and a professor at the Universidad Católica de Chile. She's currently focused on processes of sediment generation and the downstream transfer of that material in the fluvial basins of central Chile. Today, she will be sharing insights on the effect of a shifting climate on the dynamics of mountain fluvial systems. So without any further ado, we are so happy to have Dr. Villaseñor join us today, and the floor is yours.
Thank you, Juliet, and thank you for the invitation. Hi to everyone that is looking at my presentation. And yeah, I'm going to be presenting the research that I've been doing over the past years in central Chile. I'm going to be talking about sediments and where it comes from, how it moves around the systems, and how the change in climate here in central Chile is affecting those processes. And here's a list of all my co-authors. Most of them are from Universidad de Chile, Universidad O'Higgins here in Chile, and also from Estación Experimental de Aula Dei in Spain. But to put things in context, I'd like to start my presentation showing this figure of the sediment routing system that describes how the sediment is generated and how it moves around from source to sink. And there are different things happening in this figure, but I'd like to highlight some processes that are very important, at least here in the Andes, to generate sediment. Like landslides, for instance, we can generate a lot of sediment that moves around very quickly. I'm going to show a little bit of that during this talk. Also, glaciers here in the Andes are very important in not only shaping the landscape, but also in generating a lot of sediment. And with the climate change, the drought we are having here in central Chile, they are becoming more and more important as well. And that sediment that is created in the mountains eventually gets into the fluvial network. It moves around downstream. It gets all the way to a river mouth. Here I'm showing a satellite image of river plumes after a rain event in winter a few years ago. And eventually it accumulates at the bottom of the ocean. I used to look at the marine sediments to understand these processes, and now I'm looking at these processes happening like on live mostly on the fluvial basins. And these processes of sediment generation and how climate is affecting these processes is becoming more and more common to see papers on this topic in the literature, mostly because the hydrological regime in the mountains is changing. As I mentioned, glaciers are becoming very important, but also the precipitation regime is changing. So that changes also not only where the sediment is being generated, but also when the sediment is moving. And here I have here some examples of very recent papers that talk about this topic. And I have here on the right side of the screen an article that's in Spanish, but it's related to a conversation that happened a few years ago here in Chile about how water from some rivers could be moved to other fluvial basins that have less water because of the drought we are having right now, and how some politicians were saying that the water is wasted when it gets to the ocean. And that's because, well, there's not much knowledge about the role of fluvial basins, not only in transporting water, but also in transporting sediments and nutrients that are very important for ecosystems downstream and in the ocean as well. So looking at how the sediment is moving and generated, it's relevant for different aspects of the ecosystems as well. And climate change is affecting, as I mentioned, changes in the precipitation regime in the mountains. It's changing from snow to rain. There is reduced snowpack. Glaciers then are releasing a lot of more water than in the past. We have extreme precipitation events that move a lot of sediment in very short periods of time. That changes slope stability, can change sediment yields, along with discharge, water discharge. Also, there might be changes in vegetation cover that also influences erosion. Because of the shift in climate, we can also have increase in fire events that affects, erosion as well, and processes of sediment generation, and eventually changes in fluvial morphology, and in more drier areas, aeolian sediment transport as well. So as climate changes, a lot of things are changing in the surface of the earth as well. And in Chile, I mentioned that we are going through a drought that we've called the megadrought, because it's been 15 years of reduced precipitation of up to 75% compared to the pre-drought period. And here's a map in the left of the standardized precipitation evapotranspiration index by April 2025. So it's a very recent image that is showing how south central Chile is having a drought. And this has been a permanent feature since 2010. We've had a couple of more normal precipitation years the two recent years, but still we are considering that we are not over the drought. The graph here on the right side of the image is showing in gray, black, aligned with the precipitation in Santiago, the capital of Chile, that is located here, where I'm showing with my cursor. And we see that, precipitation is quite variable here in the Chile because of ENSO, El Niño and La Niña years. But since 2010, it's been quite consistent that we have very low precipitation levels. The past 2 years the past year was a little bit more normal in terms of precipitation, but still we are very low in precipitation, and that's having consequences on the hydrological regime of the basins. And the blue line is showing a regional a compilation of 48 stations in central Chile that is showing pretty much the same. So this is the context. We have less water moving around, and for instance, there is less stream flow in the rivers. This is what is showing this map on the left of the screen. So all these dots are gauging stations in central South Chile, and the red colors are the anomalies, the negative anomalies of stream flow compared with the 1980-2010 period, like the pre-megadrought period. So it's quite consistent that we have less water flowing in the rivers, and that results in less sediment moving in the rivers. That is shown here with this image on the left. This is the discharge, the ratio comparing the megadrought period and the pre-megadrought period between 32 and 40 degrees latitude, which is central South Chile, and most of the gauging stations are showing the same, that we have less sediment moving around. So there's less water, less sediment. And the question that I have after looking at all these antecedents is how variable are the sediment sources and transfer paths in river basins in the context of the megadrought? What is happening with that little sediment that is moving around? And to answer this question, I've been studying the Maipo River Basin, which is located in central Chile. Is the basin that feeds with water the capital of Chile. Is quite large. I'm focused on the upper part of the Maipo River Basin that is called the Alto Maipo Basin. It's over 4,000 square kilometers, quite large. It encompasses the entire mountain that we have here in central Chile. And I've been collecting sediment samples in 6 locations that are shown here with the triangles since 2019. So I've been collecting samples during very dry years and more normal years in terms of precipitation. Here in the right, there's a geological map, and also with with this light blue color, the glaciers here in the basin. And the geology is very interesting because of the research that I'm doing. Because I study sediment provenance, is that we have these kind of north-south oriented bands of different lithological units. So the geology can be divided in kind of 3 different types of rocks. These in more orange, reddish colors is Cenozoic lithological units. Then we have a band of Mesozoic units. And then in the border with Argentina, we have a volcanic rocks, quaternary volcanic rocks, the current volcanoes. And this basin have an eval regime, so the higher discharge occurs during the spring and summer months. And that's because glaciers supply a lot of water during these months. Over 50% of runoff contribution comes from glaciers in the basin, and a lot less from rain. And this basin have 4 main tributaries: the Maipo, that is coming from the south, the Volcan River. This is important because I'm going to be talking more about this river later in the presentation. The Yeso River from the north, and the other one, Colorado River, from the north west of the basin. So as I mentioned, I've been collecting sediment samples since November 2019 in these 6 locations, always during the period of higher discharge. And I've been collecting sediment from bars, from sediment bars, fluvial bars in these locations, and also from suspension. And it depends on how much sediment I see that the water is carrying. And here are some pictures that show how the sampling locations look like. I have been also collecting, preparing a database of geochemistry, both major and trace elements, and isotopic, mainly strontium, and epsilon neodymium, from the lithological units of this basin, because I'm going to be comparing the composition, the geochemistry, and the isotopic composition of the sediment with the same isotopic signatures from the lithological units to kind of trace the origin of the sediment. This basin have also 5 hydrologic plants, mostly like the water passes through these plants, except here in the Yeso River, we have a dam here, and there's a small lake that is trapping sediment. And that's important for the sediment provenance results then. And that dam was built in the 60s. And during the period I've been studying this basin, we had an extraordinary precipitation event in January 2021, and this is important. And that was because of an atmospheric river that impacted central Chile between the 28th and 31st of January. We had up to 100 millimeters accumulated precipitation, and the 0 degrees Celsius isotherm was about over 3,000 meters above sea level. So we had rain very high in the mountains. This was a summer storm during the driest season of the year. We don't have these storms in the summer, usually in the winter. And because of the high periods of high intensity precipitation, we had hundreds of landslides in the Maipo Basin. Here is causing a lot of damage as well. Here is a picture of one of those taken during those days. The map here to the right is showing the accumulated precipitation associated to this event and the regional distribution of the precipitation. And here in red, I'm highlighting the starry areas. So we had a lot of rain in the Maipo Alto Basin during those days. And here in the center, I'm showing a few records collected during those days. In blue is the discharge, is in Spanish, is the discharge over those days. So here we have the daily, cycle of discharge and how it increased a lot during these days because of the rain. And that came with, well, here's the precipitation in green, and that came with a very sharp increase in the turbidity of the water. So that means that there was a lot of sediment moving around very quickly, associated with the precipitation and the high discharge coming out of the river. And here, if we follow this record, a few days later, we have also some days with high turbidity, that is not associated with the precipitation event, but mostly with heat waves that we have usually in the summer, and that means a lot of discharge from the glaciers that also carry sediment. So as I mentioned, I study sediment provenance, trying to understand where the sediment is coming from, to understand, sediment transfer paths and what's happening in this basin. So I had the opportunity, because of the precipitation event, to go to the field on the day after, right after the event on February 1st, to collect some sediment samples only on 3 sampling locations that I'm highlighting here with the yellow triangles. And that's because there wasn't access to these upper sampling locations because of the landslides. But I had the opportunity to look at the river right after the event. Here are some pictures, and here is a video. So the water looks carrying a lot of sediment. Here also we have a small landslide, that reached all the way to the fluvial network. And here's a small video showing how the river looked like. So the water level was quite high and there was a lot of sediment moving around. We also compile all the landslide reported from the official reports, mainly from the Geological Survey here in Chile, to have an idea where the landslide happened. But we also mapped many landslides in some places where the Geological Survey didn't go and look. And I mentioned that I compile a database of the isotopic composition of the geological units that we have here in this basin. And this is the result of that compilation. This is just for the isotopic composition. And what's interesting is that for each lithological unit, we can define like spaces in this isotopic field in which we can differentiate each lithological unit by their isotopic composition. So the colors here are matching the geological map. So here with the purple is the volcanic units, the quaternary volcanic units. Here in this area, we have towards the right of the graph, we have the Mesozoic units that are cropped here in the upper part of the basin. And here with the yellow-orange colors are the Cenozoic units. So by measuring the isotopic composition of the sediments that I've been collecting and comparing that to these isotopic fields for each of the lithological units, we can start to understand what are the lithological units that are generating more sediment, and then how it moves to the places where we have collected this sediment. Okay, so as I mentioned, we collected sediment starting 2019, and we also had in the meantime this precipitation event. And these are the results. Most of the data points, and here I'm comparing the isotopic composition of the sediment that was collected from suspension and also from the river bars as well. So most of the sediment, if are within this area that I'm showing here, so have a signature, an isotopic signature that's compatible with material derived from erosion of the quaternary volcanic unit, this purple area, and a mixture of Mesozoic formations that could be this Rio Damas formation or the Rio Colina formation. And all this rock outcrop here in the very higher parts of the basin, here we have the volcanic rocks, and then we have the Mesozoic rocks. We have an exception, which are these samples in gray, the gray triangles, that have a signature, an isotopic signature is quite different. And these are the samples collected in the Yeso River that I mentioned that has a dam upstream. And the isotopic composition of these samples is very compatible with the rocks that surround this sampling location. So we see that we interpret this as a very local influence on erosion happening just around the sampling location, and the sediment is getting to this point that we've been visiting over the years. And that means that the dam is trapping most of the sediment that is coming from upstream that may have this Mesozoic quaternary signature. And here I have highlighted the summer 2021 event samples that I collected on February 1st, right after the event, that also have a very different isotopic composition. That could be interpreted, that we interpreted as a mixture of Cenozoic and Mesozoic signals. So we lose this strong quaternary isotopic signal, and we can have something like more in between. A very rapid change in composition then. So how we interpret these results in terms of sediment generation and transfer in the Maipo Alto Basin? Most of the sample show a strong signal from the upper sections of the basin, the quaternary volcanic units, the Mesozoic units. And if we think about the quaternary volcanic units, the glaciers, most of the glaciers, and that's why I'm showing here this map again, the geological map with the glaciers on top, are located on these rocks, the quaternary volcanic units and the Mesozoic units. So what we think is something that has been mentioned before for this basin that has to do with the subglacial connectivity in the context of the megadrought. We don't have much snow in the winter, so there's no much runoff coming from the snow, as I mentioned at the beginning of this presentation, but a lot of water coming from the subglacial system, especially in the summer when the heat promotes the melting of the glacier. And here's an example of one of the glaciers. Here's the main volcano in the basin, the San Jose volcano. Here is this Nieves Negras Glacier. And here's a video that we visited. We visited this basin, this glacier, in April 2024. And you can actually see the water coming from under the glacier and loaded with a lot of sediment. So apparently that's becoming a very important aspect of the sediment being supplied to the basin, that is coming from under the glaciers and carrying the strong signal of the rocks that the glaciers are eroding. We don't have a strong signal for most of the samples from the Cenozoic units, meaning that there's no connectivity in the middle to lower sections of the basin. And connectivity, I refer to hill slope to channel connectivity. So apparently the system, there is sediment on those hill slope in the middle and lower sections of the basin, but that sediment is not moving. But what happened during the event? As I mentioned, we compiled the landslide that happened during the event, and we also mapped many of them, and this is the result, the map here at the center. So we had hundreds of slides, about 300 landslides that happened between January 30th and February 1st of 2021. And most of them happened in the middle to lower sections of the basin. The snow line for the event was about 3,300, 3,500 meters above sea level. So we interpret that snow that fell during the event resulted in a temporary reduction in runoff and also a temporary shut-off of the subglacial hydrologic connectivity because of the lower temperature. So the glaciers weren't supplying much water during those days at least. But these landslides that occurred in the middle and lower sections of the basin promoted the hill slope channel connectivity and rapid sediment transfer to the fluvial network. And I have here some pictures. I showed this picture earlier in the presentation, this small landslide, getting all the way to the river, and some satellite images also showing, how various creeks were activated with debris flow mostly, and sediment getting directly to the fluvial system. Here, this is a satellite image representing this area that I'm showing with a yellow star, and way higher in the base. And also we have the activation of debris flow, also feeding sediment to the system. So apparently that during these days of the event, all these landslides were supplying sediment, and the other system that used to generate sediment during the summer wasn't working that much. Here I have several satellite images that represent how the basin looks like in terms of snow cover since 2019. And because of the megadrought, there isn't much snow at the end of the winter season. There is no snow, mostly only the glaciers in the summer. But this is how the basin looked like right after the event. This is a satellite image from February 2nd, the day after we took the sediment samples. So there was a lot of snow, cold temperatures still high in the mountains, so not much runoff coming from there. But a month later, in March, we came back and we collected sediment in the same sampling locations, and we see here that all the snow had gone. And these samples, the March 2021 samples, fell within the normal or the regular part of the isotopic signature. So sediment samples collected 1 month after the event have a provenance signal that is from the upper sections of the basin. So that means that all these landslides that were supplying sediment were not supplying sediment anymore 1 month after the event. And we had recovered the system to the normal, let's say, normal summer functioning in terms of sediment generation and transfer. And we lose also the Cenozoic signature that may come. So everything that used to happen in summer is still was happening again 1 month after the event. So what have we learned from this small study is that the landslides of this precipitation event led to a very rapid shift in processes of sediment generation and transfer in the Maipo Alto Basin. And the question that I ask myself is, do extraordinary events lead to extraordinary sediment sources? And I showed a graph that showed a very high turbidity, and we saw a lot of sediment moving around. So the question then is, this high sediment discharge to the landslide resulted in sediment transfer to the river mouth. And here I'm showing in the right a map of the larger Maipo Basin. In green is the area that I've been studying. But we collected also some samples downstream all the way to the river mouth to see whether this signal, this isotopic signal that the landslide generated was transmitted or not all the way to the river mouth. And those are samples that are still under analysis. We know the answer in a few months, I hope. But after this study of looking at the larger Alto Maipo Basin, we wanted to understand better what these processes of sediment generations are working. And we decided then to look at smaller sub-basin within the Alto Maipo Basin that is called the Volcan River Basin. So here's the Alto Maipo Basin, and in orange is the Volcan River. And this river also preserves the geological differentiation that I explained before, the Cenozoic units towards the lower part of the basin, Mesozoic here in the center, and the volcanic units here in pink. So the question here is, how variable are sediment sources and the transfer pathways? What is happening really? Is only the glacier, or whether there is something else producing sediment and sending it to the fluvial network? And so we've made, because this is a smaller basin, it's over 500 square kilometers. So we are able to do more like field site geological and geomorphological observations as well. So we did geomorphology and also sediment provenance. And sediment was collected from this point that is, downstream the main units and main glaciers of the basin. So we come up with a geomorphological map that I'm showing here. I'm not going to go into details of the map because there's a lot of information going on here. But we were able to discriminate between geomorphological, morphogenetic domains and identify potential sediment sources. But talking about field observations that I'll be showing in the next slides, we have several alluvial fans that show that there is activity, there is material coming out, but appear to me be mostly disconnected from the fluvial network. So the sediment accumulates here kind of in the lower part of the alluvial fan, but it doesn't move much more than that. In other parts, we have talus cones, with a lot of sediment, but with no signal of sediment moving because of water, only because of gravity, and also quite disconnected from the fluvial network. So there's not much evidence of sediment that is moving from the hill slope and getting into the fluvial network, if we look in detail. And this is in the foothills of the volcano, which I've shown is seems to be a strong signal for the sediment in the basin. And also what we saw, and this was a picture taken at the end of the winter, is that some creeks, and this, I'm showing here a person just for scale, that are filled with snow and covered with gravel, with sediment. And this material over the spring, especially, and usually over the summer, will become water and potentially will be water to carry sediment all the way down to the river. So this is kind of material that is about to get there, but not quite during the time we took this picture. So this is another potential sediment source for the sediment that is moving in this basin. So we took sediment samples from this sampling location that we call Boca Toma, that in Spanish means water intake because it's close to a water intake in this basin. And here I'm showing we collected sediment. The results that I'm going to be showing here are sediment samples collected from October 2022 to February 2023. So this is after a dry winter. And here's to the left is a picture from October 2022. And to the right in January 2023. The scales are different, but we see here that there's more water flowing in the river and, it's carrying sediment in suspension. And also here we are focused on suspended sediment. And here we change the approach. Instead of looking at the isotopic system, we look at the geochemistry, and this I'm going to be showing results from rare earth elements content in the sediment samples. Just to find another way to discern sediment provenance in the basin, considering the geology of the Maipo Basin. So what I'm showing here in the blue and the yellow areas represent the compositional areas of the Mesozoic units in blue and the Cenozoic units in yellow. Cenozoic units meaning the quaternary volcanics and these patches of Cenozoic volcanic rocks. And the Mesozoic units are everything else, the blue and green lithological units that are shown here in the map. And what I'm showing here then is that most of the sediment samples collected here in this Boca Toma sampling point are very, they have a composition that is very compatible with Cenozoic units. That means the influence of volcanic units that I'm highlighting here with the red circle, or the Cenozoic units as well, here this band, because there's a glacier that's potentially eroding that sediment. I mean, that lithological unit that may then result in material being supplied to the system. There's only one sample, this one in yellow, that was collected in January 2023 that have a different composition that is more compatible with the Mesozoic unit. And that was a sample collected a few days after a very local convective rain event that happened in the north part of the basin that resulted in a debris flow. And here I'm showing a picture of that taken during those days. The river is flowing to the right, to the left here, and the debris flow came from the north. Here are the deposits of that debris flow. So that debris flow, that sedimentary signal apparently, because this creek is coming from this part that I'm showing here with my cursor, where there is a lot of Mesozoic rocks. So that's a signal that was carried all the way down to the sampling point, even a few days after the event, and that is shown here in the composition of the sediment. But the sediment that was collected 1 month after, in February 2023, and this is very similar to what I shown with the other study, have again as a geochemical signature that is quite compatible to the other samples collected before the event, reflecting a supply of sediment from Cenozoic units that we interpret again as a very important role of the glaciers eroding the volcanic units as well as the Cenozoic unit here. So apparently these events are producing a short-term effect in sediment composition that a month after, when we go back and sample, it's gone. So in summary, sediment provenance signal from the upper sections of the basin, the Maipo Basin, is very strong, talking about a very important role of the glaciers. And also, this is also talking about this signature that is carried all the way down to the exit of the Maipo Alto Basin and also to the exit of the Volcan Basin. It talks about that the hillslope and channel are disconnected mostly, except when we have these precipitation events that can be because of convective local precipitation or regional precipitation events like atmospheric rivers that get into central Chile. The question is, what will happen during a wet year, whether this signature in the sediment will change or not? Because all the samples that I've shown until now have been after very dry winters. And what happened is that the following winter, and that's what I'm showing these pictures here, the satellite images, the winter after the winter of 2023, right, was quite wet. And here I'm showing the snow cover at the end of October, at the end of spring of 2023, compared to the end of the spring of 2022. And the difference is quite remarkable. And we have some sediment samples collected during that season, the season after this wet winter. So we hope to find a difference. We haven't analyzed those results yet. And here I'm showing a precipitation record, and we see here 2023 being a very wet year here in Santiago compared to the previous years. But also thinking about the future, for Central Chile, there are projections of a drier climate. So that means dry winters will be more frequent, meaning that probably the glacier will become more and more important in providing sediment, in producing this connection. And the question is whether the future will be a very strong signal from the glaciers with episodes of new sources feeding the system whenever these precipitation events happen. And last but not least, I'd like to comment about the communities of the Maipo Basin, because this research is happening in a basin where there's a lot of people living, and moving around the basin, collecting sediment samples, I become interested also in getting to know the people that live here in this basin and see the river more frequently. And they have become some sort of partners in my research because they communicate whether there's something different happening with the color of the water, for instance. And I've been part of this project that is called I'm going to say it in Spanish, Encuentro Científico de la Cuenca del Maipo. It's a scientific gathering in which scientists, NGOs, local communities get together to talk about the basin and what is happening, how it's going to be developed, what's the future of the basin. And these are pictures of the first gathering in 2023. And we just, last winter, we had the third version of it in different parts of the basin, connecting with different communities along the basin from the upper, middle, and lower parts of the Maipo Basin, and learning what they think about the basin, how they live in the basin, and experiencing the interest they have in the research that we do, not only my research, but research that other people are doing here. And there are some other NGOs or city science projects that I have been involved with because they have also sediment samples, especially during these events, because they live right by the river. And thus, this experience have led me to realize, in a way, that science in the Maipo Basin occurs in the context of the megadrought, a projected climate, but also in a basin that sustains over 8 million people, agriculture, water facilities, industries, and also several socio-ecological conflicts. And then I get to ask myself how I make my research more approachable to the people that live here in the basin, and kind of give them information that will be helpful for them and to their lives. And with that, I'm going to be finished with several pictures of people that have helped me in the field to collect samples over the years, and I'm open for questions. Thank you.
Thank you so much. What a great talk. The floor is now open for questions. You can feel free to use either the chat feature or the Q&A feature, and we'll give people a few minutes to type those out. If no one has any questions, I just want to remind everyone that this webinar will be posted on the SZ4D YouTube channel later today. So feel free to rewatch or send to your colleagues or maybe your students. And if a question comes up later that you forgot to ask, feel free to send us an email and we will pass it along.
Yeah,
Since
you
I'm
can send
not
me an email. So here I have my email address.
perfect.
Okay.
And I'm not seeing any questions. So without further ado, I want to thank you again, Tania, for giving such an excellent talk. And we really appreciate your time and to participate in this webinar series. Thank you everyone for
Yes.
joining, and we hope you have a great rest of your day.
All right.
Bye. Thank you.
Bye-bye.